All right, man, now we're going to program using recursion. Hopefully you enjoyed the intro. Um, Probably didn't make much sense until you start programming. So we're going to look at 5 little mini programs. Actually, we're just going to make them functions inside of one main. So we're going to use this using REPL. And the reason why we're using REPL, you just send me the link. There's no uploading files. Just send me the link. So let's do that. Let's take a look at the 4 programs. We're going to print multiple times. We're going to take the sum of numbers 1 to 5, some of the range of numbers. Say if I want to add the numbers 6 through 12, multiply 2 numbers, and then power of 2 numbers, which you're going to do on your own. I'll guide you through the first 4. And I guess I'm going to change that to 5 programs now that I count. Go. There should be a save button there. All right. So what I want you to do is go to RepWhip. I know about a third of us are using this. There, we haven't. I'm pretty sure I showed everyone how to use it before. Let me pause this for a second to figure out how to log out. All right. So if you go to RepWhip, if you haven't used this before, we're going to use the login. And I'm going to log in using Google. There might have been a step that you had to get to. And we're going to be using Python. And then you're going to form a new REPL, which is just a new idea. And I'm going to make sure I'm using Python. And I'm going to call this Intro to Recursion. There we go. And create REPL. There we go. So here's our main. If we want to run this, nothing happens. So what I usually do here is just like we've always been doing is we start with a main. And way down yonder, I'm going to call that main. To run this quite often, it works beautiful. So very first thing I actually do is we're going to print multiple times. All right, so I'm going to call this R1, and we're going to print. So we're going to create a function called R1, and it brings in a value. It's going to bring in this value 5. Now, from reading, I'm sure you did, and the video, you realize that with recursion, there is what's called a base case, and there's also a recursive case. So let's take a look at this base case. I wonder if I can make this any bigger. There we go. Yeah, base case. So the base case will always be what I call the escape, the end. So what we're going to do, we're going to start with, I think we're starting with 5, and we're going to count down, and we're going to look for an escape. So if n equals 0, usually it's n equals 0, n equals 1. Use a double equals, Mr. Snyder. If n equals 0, we can return a value. I'm going to return 0. And just for kicks and giggles, I want to print out here that we've actually reached base case. I guess we could print out, see what n is. Just to get a full understanding of what's going on with recursion. Now, in the recursive case, this is where the repetition comes in. And we're going to say else. So this is how we escape. Otherwise, we're going to keep on moving. And we could say we could print. We're in the recursive step. And we are going to return, and we're actually going to call the function inside the function. So that's what recursion is. So we're going to call R1, and we're going to drop it down by 1. And I just want to see what n is in this case. That's it. We're going to see if this runs. I'm going to run it. At least I thought I was going to run it. Wonder where, if I have an error, where it would be. R1 of 5, n minus 1, else, saved. Hold on a second, let me figure out what's going on. Well, it turned out my main was indented, so it never ran. So it looked like that, and of course, the main never ran. So what you see here is we put in a 5. Is 5 equal to 0? No. So this runs. Recursive step is printed. 5 is printed, and then it returns this function sub of 4. 4 equal to 0? No. So it takes this step and prints. Once we finally get to the base case of 0, you get base case 0 and returns 1. Now, just for kicks and giggles, I'm wondering what would happen if I would turn this return off. Nothing. I wonder what would happen if I turn this to like a 3. And oh, so I'd encourage you to pause here, play around with some numbers, just to get a feel for what's really happening in this. A good place to pause. Just play around with what happens if you change some things here, return some things here. Kind of odd would be what happens if you take an n plus 1. Kind of interesting. So go ahead, play with that. Pause. Play with this basic recursion program.